Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is what are the various modifications which we are going to done in inclusion and confinement. In these various different types, we are going to understand. So, this soil nailing for excavation support, we will see in different scenario. Now, here we are understanding these, what are the various expected outcomes, what are the various techniques we are using for that get the expected outcomes for this particular technique. In this soil nailing for excavation, a deep excavation needs support to prevent collapse. So describe how soil nailing can be used and detail the installation process. So in this site investigation, excavation depth is 10 meters. That soil type is silty clay with moderate shear strength. These are the site investigations for this soil nailing for our excavation. These are the design parameters which we are going to consider. Those are nail spacing 1 meter horizontally, 1.5 meters vertically, nail length 8 meters, nail capacity 50 kilonewton per nail, soil shear strength is 20 kPa and its angle is 25 degrees. Soil unit weight is 18 kilonewton per meter. Factor of safety that is desired is 1.5. These are the various design parameters which we know. Now, how we are doing this process? So, in this design calculation, the one is the stability analysis without soil nails. So, here before introducing the soil nails, how the stability analysis is there, how the structure is going to stable. In this, the first step is stability analysis without soil nails. This calculate lateral earth pressure at the bottom of excavation, that is equal to P is equal to Ka gamma H square is the formula for understanding the lateral earth pressure. So in this Ka is the active earth pressure coefficients. Now finally, after doing all the calculation, 702 kilonewton per meter square is the pressure, lateral earth pressure for the from the data. So in this, the next one is design of soil nails. In this, the first thing is number of nails required for the meter vertically, number of nails required for the horizontally, both vertically and horizontally, how many number of soil nails are going to required, and after the total number. So now in this, so based on that already we understand this vertical spacing and what are the considerations we did, that is based on this we are going to calculate how many number of soil nails for each type. In this, according to that, the number of nails for 10 meters is there. Vertically, the spacing is 1.5. It means nearly 7. 7 number of soil nails. Those nails are required for vertically. Coming to the horizontally, 10 meters by each, the spacing for horizontally is the 1 meters. So that is equal to 10. So number of soil nails required per meter, horizontally 10 numbers. So vertically 7 numbers. Now total number is equal to horizontally those are 10, vertically, and those are we are going to require how many number of total nails are required. So that verification of soil capacity. So now we are choosing the capacity for resisted by each nail, force per nail. So P, total number of nails. So that force P is equal to 702 kilonewton by 70. So 10.03 kilonewton force is resisted. So each soil nails is going to resisted the 10.03 kilonewton. So check against the nail capacity. So generally 50 kilonewton, it is less than 10.03 kilonewtons. It means it is in safer condition. Now, design for factor of safety. Additional resistance provided by the nails, additional resistance. So that is equal to 3500 kilonewton. According to the total resistance force, P plus additional resistance. So totally 4,202 kilonewton. In this, total resistance by the peak gives the factor of safety, that is equal to 5.98 after the calculations which we made. So in this, the installation procedure, so excavate the soil in the stages. So excavate the soil in 1 meter depth increments. Ensure that each stage of excavation does not exceed 1 meter to maintain stability. Drill holes for nails. So drill 8 meter deep holes at specified intervals. So that is 1 meter horizontally and 1.5 meters vertically. So insert and grout nails. So insert steel reinforcements nails to the drilled holes. So grout the nails to ensure proper bonding with the surrounding soil. So insert and grout nails. Attach shotcrete facing. So after nail installation, apply shotcrete facing to the excavated surface. The shotcrete facing provides additional support and protection. So this is the installation procedure. After the installation procedure, we are move on to the monitoring. So install inclinometers, regular inspections, helpful for the getting the whenever the soil nails and what are the for the structure is within the design limit or not. It gives the better understanding. So place inclinometers at strategic locations to monitor lateral movements of the excavation level, for monitoring the lateral movement of the excavation of the wall. Regular inspections, inspect the condition of the soil nails and shotcrete facing periodically. So they are going to ensure, so regular inspections, those are going to ensure the safety. So we are ensuring the nail tension remains within the design limit or not, we are understanding using by these regular inspection. So according to all these calculations and everything is done, finally we will get this outcome, that is stability and performance and durability. The soil kneeling systems provide adequate lateral support, preventing excavation wall collapse, and the factor of safety is significantly improved, ensuring the excavation remains stable throughout the construction process. The regular monitoring and maintenance will ensure the long-term effectiveness of the soil nailing system. And one more is ground anchors for stabilization. In this, slope angle, soil cohesion, unit weight of the soil, height of the slope is mentioned. So we are going to calculate the factor of safety first without anchors. So first we are understanding the factor of safety without anchors. Now once we calculate the factor of safety without anchors, approximately that is equal to 1.955, indicating the slope is stable. However, we are aiming the factor of safety of around 1.5 for added safety, especially after heavy rainfall, which can reduce the factor of safety. Now, ground anchors, we are facing those ground anchors, length of anchor, design load per each anchor we are understanding. After that, design these ground anchors, we are moving to the drilling and installation. Drill 10 meter deep holes at designed locations according to the specified spacing. As per the spacing, we are going to place the anchors which what we designed. Now insert the anchors and grout them to ensure they are securely placed within the place. Insert the anchors and grout them to ensure they are securely placed within the soil. The grout provides additional bonding between the anchor and the surrounding soil. So this tension to the anchors to each 120 kilonewton, 80% of the design load. This pre-tensioning helps in providing immediate stabilization to slope and ensures the anchors work effectively under loading condition. This the monitoring. Install inclinometers, periodic inspection. So in this, to monitor lateral movements of the slope, this allows for real-time monitoring of any slope movements and helps in assessing the effectiveness of the installed anchor. In this, periodic inspection of anchor tension to ensure they remain effective over the time. This includes checking for any loss of tension in the anchors and retensioning them if necessary. So this monitoring helps us to maintain the expected outcome in long term and also understand the whatever the technique we ensured in that part we used for that particular expected outcome, finally we'll get the desired limits. So based on according to this monitoring, we are understanding whether it is within the permissible limits or not. So expected outcome from these factor of safety with anchors, the additional resistance provided by anchors increase the overall stability of the slope. To achieve factor of safety of around 1.5, the anchors need to provide sufficient additional force to counteract the driving forces acting on the slope. So let's calculate contribution of anchors to the factor of safety for additional force from anchors. To total anchor force, so number of anchors into tension in each anchor. So assuming anchors are installed in a grid pattern, it depends. So different kinds of patterns are there. We are assuming it is in grid pattern. Now number of anchors, this is the using this formula. Finally we are understanding the how many number of anchors, that is 33. Total anchor force is equal to 3690 kilonewtons. Now contribution of this factor of safety, the anchors add a resisting force which can include the factor of safety calculations. So now this factor of safety with anchors, here the additional force provided by the anchors is significant, that increasing the factor of safety to the desired level of around 1.5, assuring the slope remains stable even during adverse conditions like heavy rainfall. So these are the various parameters which we are going to understand for additional forces, and under various conditions, those are soil nailing, ground anchors, soil reinforcement with the geotextile, soil reinforcement with the geogrids. So many difference are also there. Soil nailing for excavation support. Under different techniques we are going to choose for getting the expected outcome. So it depends upon the various parameters. Those are type of the soil, and any kind of disturbances may occur, unexpected forces may occur. It depends upon the various parameters. So based on that we are going to choose the technique. After that, each different technique has their own kind of approach. So according to that, for this nail having their different kind of things, even each kind of technique also, based on the parameters, soil parameters, they are going to change their process. Not completely, in partially we are going to understand the way of calculation is depends upon the what they given. So based on the given data and understanding the soil properties, we are going to choose the appropriate technique. So after that technique, we are getting this expected outcome or not. Finally, based on the monitoring and maintenance is very required. Once the process is done, also we are going to, for the project longevity and sustainability, we have to maintain that monitoring and maintenance for the design properties. So these are all the some of the examples which we consider, practical examples which we are going to consider in this particular unit, that is modification by inclusion and confinement. These are the some of the scenarios what we understand. Few more are there. So according to this, based on this, they are also easy to understand. According to the scenario and the problem statement, we are following the process. So based on the technique, what technique we are choose, it depends upon the project requirements. So based on that project requirement, what are the soil conditions are required. But actually what are the soil conditions are there. For improving the soil condition, we are choosing the various techniques. So these are the some of the practical problems which we are observe under the modification by this inclusion and confinement. So what about the remaining modifications? Those categories are there in our thing. So we will see those in our next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.